Alright guys, I promised you a follow-up video once I'd worked out what I was going to do with all of the wires from the X115, X115 pinout. So what I did is I walked through the GM Upfitters electric layout specification, the 800-page document that I referred to before. Also went through the wiring schematic and worked out what each of these wires runs to and worked out what I'm going to do with them. As I said in one of my past videos, the easiest thing to do is to track the circuit and that lets you check from various component to various component, whether that be the ECM or the body control module or the fuse block or the MAF, whatever it is. You can follow the circuit around and work out where all these wires are going. So the first one is number 3, which is the actually the first one is number 2, which is here somewhere. It's 42. Should be the electric variable displacement control. Rather than actually walk through either all of these, what I might actually just do is, unless this is it, yeah, electric variable displacement control, blue-brown wire, circuit 7573. So this is going to get capped. This runs to the AC compressor solenoid, and I may want to run this in the future. So what I'm actually going to do with this is run it to a 12-position Delphi. You'll have to excuse the accent, I might have the pronunciation wrong, but a Delphi GT280 12-pin connector is what I've bought, or what I've got ordered from Waytech. And I'm just going to take this and pin it up and probably put it into either the male or the female connector and not have a connector on the other side. But that means that I can do two things. One, I can depin this from the fuse block pretty easily, the actual truck body, once I have this wired up. So if I ever need to remove the harness, I don't have to remove hard wires. I can just unpin all of these, not just one, but all of these from 1 or 2 or 3 connectors. And the other thing is I can plug these off, and if I don't use them, they can just stay there, and if I do use them, then I've got a pin on the other side that I can run a wire into and then activate this. So this is the control for the AC compressor solenoid, and it goes to the HVAC control module K33. So for now, that's going into my 12-position connector, and I'm going to put that at pin number 5. The next one is the MIL light, the check engine light. That's going to go to the same 12 connector, and I'm going to put that at pin number 12 so that I know that I have a wire that runs to this. And the note that I have here is that that basically the computer supplies a ground to activate the light. So you just hook a powered malfunction indicator light to this, and then if there's any problems, the ECM will ground it, and you'll get a light. Next one is the Cruise ETC. This one here. Oh, maybe not. It's 5, 7. Hold on, I'm going to find that. It's 5, 4. Cruise ETC TCC brake signal. It's white, it's dark blue. This is going to the 12th position in pin number 1. So pin number 1 and pin number 12 will have something connected on the other side. The rest are actually just going to be capped. So this is the brake switch signal. It's 12 volts when hot, when the brakes are applied. The ECM supplies the ground, and so it's open when you're not on the brakes, and when you're on the brakes, 12 volts goes through this. Now this is normally controlled by the body control module, but because we don't have a body control module to send the 12 volts, and what I'll end up doing is connecting this to a switch for the brake. That will just be a sort of an on-off switch, and similar to the way your rear brake lights work. When you depress the brake, this will get 12 volts and will send 12 volts through to the ECM and then onto the TCM to let it know that the brakes are applied, and I believe to unlock the converter. There may be some other stuff going on with the TCM that it needs to know when the brakes are applied. I haven't gone into that a lot yet, but yeah, 12 volts when the brakes are applied. So that's an important one. The next is 5 and 6, which are the high-speed GM LAN or the CAN bus. This one for the engine. So this is white, it's 2501. There's also a 2500 at pin 6. So these run to X133 and X143. I'm going to keep both of these, and they'll collectively run to the OBD2 connector at pins 14 and pins 16, pin 14 and pin 6, not 16. So 14 and 6 respectively. And these two will also be connected with a 120 ohm resistor. So the way this GM LAN or the CAN bus or the high-speed serial bus, whatever you want to call it, the way this works is they act in pairs, and they send signals backwards and forwards across all of the modules. And to terminate them, you end up using a 120 ohm resistor. And that resistor is there just to stop the reflection of signals back, so that you don't have signals bouncing backwards and forwards and I guess noise on the system. So this will get connected into the OBD2 connector, and then I'll connect it with its partner, wire number 6, with a 120 ohm resistor just across it to connect these two together, and that will act as sort of two legs. One leg will go into the OBD2, and then a second leg, which is really just the resistor between the two of these, but if you want, it's sort of like a Y junction where one of the connectors goes to the OBD2 and the other one goes to the 120 ohm resistor. So that's what I'm going to do with those two. The next three, so 7, 8 and 9, if I can find them, we'll just grab 9. 9 will do. This is 9, brake apply sensor signal, dark blue, yellow. This is 5361. There's also a 5359 and a 5360. So 59, 60 and 61. And these are the brake apply sensor supply voltage, the low reference and the signal. And they all normally run to the brake pedal position sensor and then across to the body control module. So this supplies a more precise position to the body control module of where the brake is exactly. And then if the brake's applied, the body control module sends the 12 volts down the wire that we already talked about. Well, I don't have a body control module, and I'm going to send the 12 volts directly from the brake to the ECM. So I don't need wires 7, 8 and 9. They're going to be capped, but they're, as we talked about before, they're going to go into my 12 position connector at pins 2, 3 and 4. So that's how I'm going to handle these. Okay, there's 7. This might be 8. This is 10. The accelerator. Oh, okay, so this is the next one. Okay, so 10, accelerator pedal position signal 1161. 11 and 15 are not used. 16 is the accessory wake up data signal, and then you have 18 and 19 both being accelerator pedal, and then there's a couple more, and then there's 25, 26 and 27 are all accelerator pedals. So all of these are going to a separate 6-pin connector. So there's I'm going to use a 6-pin connector for my accelerator pedal. The accelerator pedal has 6 positions, or 6 connectors to it. Pins 1, 2, 3, 4, 5 and 6 obviously, but they're actually marked on the connector as A, B, C, D, E and F. So 161, this ends up being pin 5. So this is going to go to E on my 6 position accelerator pedal connector, and then I'll have the male and the female, and then I'll run 6 wires into the cabin from this, and they'll connect up to my accelerator pedal. So if you look at the look at the wiring diagram and you get your copy of that, then you'll know that you need to use all the accelerator pedal positions. And I'll show you the data I've got here now. So we have here in position 10, accelerator pedal position signal 1161, connects to X110, and it's going to go through to my six position connector accelerator, and it's going to go to pin 5, and then I'll run that on to the accelerator pedal itself, and you can see the other. You can see from the bottom to top 1, 2, 3, 6, 4, and 5 in the light red. Then we come across here. I'll zoom out a little. You can see, come up a little bit further. This might actually be easier. So pin 10 is accelerator, pin 18 and 19 are accelerator, pin 25, 26, and 27 are all accelerator as well. You may want to just pause it here if you're going to take notes and jot this down so that you can see what's going on. And then I have the circuits, where they go from the body control module side, where they go to on the ECM side, and then I have some actions and where I'm going to route them. Okay, so let's see if we can find the wake up position sensor. This is check engine again, accelerator, more accelerator, GMLAN 2. Okay, so the wake up, accessory wake up serial data. I'm going to cap because I don't have a body control module, so I don't think I need it, but I'm not 100% sure. So if it turns out that I do need it, then it will be available as the pinout, and that's going to the 12 position connector at pin number 10. We've already covered the next two accelerator pedals, 18 and 19. 20 is the electric variable displacement control. That goes to the HVAC control module, K33. That's going to be at 12 position, my 12 position connector at pin number 6. If you remember from the start, pin 5 is the other HVAC control. So I have my AC control at pin 5 and pin 6, and then on this fuse block, which I haven't touched on yet, there's another two connectors. So these two in here control the solenoid, and then there's two wires in here that control the clutch. So I'm actually going to run the clutch controls to pins 7 and 8. So 5, 6, 7, and 8 will all be AC control. They'll be capped, so I won't have them used right at the start, but if I end up needing to, or have the ability later on to run AC through the existing compressor that's on the engine, which is obviously down here and capped off. You can see the large line and the small line, and then I have my existing AC system right there that I may end up junking or run vintage air, but at least they'll all be together on a 12 the 12 connector, and I know exactly what pins they're in. The next three are accelerator pedals in positions 25, 26, and 27. 28 through 38 are not used, and then the next two, 35 and 36, are the high-speed GMLAN serial data positive and negative. Negatives in pin 36, and they're the second serial data. Those are going to go into the OBD2, and they're going to go in at pins 12 and 13, and they'll have a resistor that spans them as well. So here's an example here. 6106 and 6105, so actually they're all right here at my fingertips, and you can see 36 and 35, a white wire obviously, and then I guess a dark blue and yellow wire. So these two connectors here are actually the, if you like, the GMLAN connector that's hooked up to the interior. So these run most of the interior modules. They also do some stuff like the ABS. They have a traction control module. There's a steering module, steering wheel angle sensor module. So these all primarily run through the body control module, and I couldn't find any other area where they were located on the engine harness itself. There's a possibility that they run down to the TCM, but I don't think so. So based on that, and some other wiring I saw, you can run them into the OBD2 connector. So I'm going to run them into pins 12 and 13, which seems like the correct pins for these two. I found a pinout diagram. The pinout diagram, I believe, is X84. So if you have a look here, keep pin 12, pin 13, X84 data link connector, and then span, like we said before, this will be the second set, span with a 120 ohm resistor. Okay, the next thing is the run 3 ignition voltage, if I can find that. Accelerator. Keeping these all together for you guys has actually turned out to be a pain because it makes it hard to find these, but you'll just have to take my word for it that somewhere in here is pin 42, run 3 ignition voltage. It runs to the power modding schematics for the body control module. I'm going to cap it. I'm not exactly sure what this thing's for. There's a possibility that it's for the 4x4 front actuator. Others have said it's capped on and off in the harness. Looks in some of the wiring diagrams it goes to the auxiliary battery schematics and the transfer case control schematics. I might not actually have this. I think it's in there, but maybe it isn't. But that's going to go to the 12 position connector at pin 11 with no connection. You know, not clear what this is doing. Power supply for front axle actuator and a 4x4 application. I'm not entirely sure. So that about sums it up. That's all 19 of them taken care of. And if you look here at what I'm going to wire to, you can see in blue, I'm going to have 4 wires run to the OBD2 at pins 14, 6, 12, and 13. And then my 12 position connector is going to have pins basically at 1, 2, 3, 4, 5, 6. It'll have 7 and 8 from the fuse box, and then 9 will be empty, and then position 10 will be that accessory wake up serial data that I'm not sure if I need that or not. Position 11 will be this run ignition 3 voltage, which I don't think I need, and then position 12 is the other wired connection, which is the malfunction indicator light. So only 1 and 12, the brake 12 volts, and the MIL inside cabin are really required. If you didn't need the OBD2 pin connector, all you're really using from this X115 is the accelerator pedal and then the brake 12 volts. Everything else is not going to be hooked up as far as I'm aware. And I could prove to be wrong, and I'll post a follow-up video if I can't get this engine started after going through all of this. But this is mostly the accelerator pedal connection, the malfunction indicator light, and then obviously the 12 volts that go to the brake. Everything else is probably going to get capped off, and then if I end up using the AC, then I'll come back and I'll be able to tell where all of these are, and hopefully it'll clean it up with a 6 pin for the accelerator, a 6 position connector for the accelerator pedal to run into the cabin, and the 12 pin to the 12 position connector to run everything else in green, and then obviously the last couple of wires are going to the OBD2. I have a drawing and a layout for this thing, so my next video will move from this connector, which is the other main connector that we've been focusing on, and we'll start talking about the fuse block and where this is going to go and what I'm going to do with all these wires. And just as a prelude, you can see that we don't have pink wires and we don't have orange wires, we have violet and red. So this L96 really is hooked up very similar to a Gen 5. The wiring is Gen 5 coloring. It's not really Gen 3 coloring, or maybe even early Gen 4. Maybe early Gen 4 is still pink, but everything you hear on the web is like just grab all the pink wires and run them to a 12 volt ignition relay. Well, this isn't quite the same. You're still going to do very, very similar with the violet wires, but it's not exactly the same as a Gen 3, and it's more like a Gen 5 in terms of the wiring schematic, or maybe maybe a late, well, it is a late Gen 4. I'm not sure if it's the same as the early Gen 4s. And then I also wanted to just show, just again, before I sign off, what my ECM looks like. So the L96 runs the E78 connector, or the E78 ECM. And you can see I have one shorter, I think this is 53 pin from memory, and then these two I think are both 73 pin. I don't know if there's anything down there. No. And on the other side there's something that says E78. Let's have a look. There we go. E78 connector. All right, well, I hope this this helps people. This went for 20 minutes, a little bit longer than I expected, but yeah, I hope this helps you guys out, and on to the next video.